Hey guys, welcome to this full stack Java course. Java is one of the most popularly used languages for desktop app development. And if you wish to learn Java full stack, then you're in the right place. But before we begin, if you haven't subscribed to our channel already, make sure to hit the subscribe button and the bell icon to never miss an update. So let's look at what's in store for you. First, we'll learn about version control systems like Git, followed by which we'll understand core Java concepts like operators, loops, inheritance, encapsulation, and so on. Moving ahead, we have a section covering Maven and Jenkins. Now it is crucial to understand front-end app development tools as well. The next section will include tutorials on HTML, CSS, and Angular. And finally, we'll conclude the session by learning database management systems like SQL and MongoDB. So I hope you're excited to learn all of this. Now let's jump right in.
In today's era, the internet and smartphones have become an integral part of our lives. We use our phones for almost all of our day-to-day tasks. Earlier, we used to shop at malls, queue up in front of banks, and make our travel bookings at travel agencies. But now, we can do all this in the comfort of our homes using smartphones. All of this is possible because of a high-level programming language called Java. Hi guys, welcome to this video that will tell you everything you need to know about the class-based, object-oriented programming language Java. Java is an object-oriented programming language that is used in a distributed environment on the internet. It is a high-level language that is easy to read and understand. Java is popularly used in console, graphical user interface, web and mobile applications, game development, and also to make embedded systems. Apart from these, Java is also used to develop software for devices. It is used not only in computers and mobiles, but even in electronic devices like televisions, washing machines, air conditioners, and so on. Online forms, banking, and shopping are possible because of Java. Java is a computer-based programming language invented by James Gosling and Sun Microsystems in 1991. He had a single motto while creating the language. It was write once, run anywhere. This meant that the code would have to be written only once, but it could be used anywhere. They named this language Oak because of the oak tree outside Gosling's office. Later, it was named to Green, then to Java Coffee, which was named after the coffee from Indonesia, and finally to Java in 1995. There are 3 editions of Java. Each programmer can learn any of these editions based on the application they want to make. Firstly, we have Java Standard Edition. This edition contains core libraries like java.lang, java.util, etc. Secondly, we have Java Enterprise Edition. This edition has APIs like JMS, EJB, JSP, servlets, etc. And lastly, we have Java Micro Edition, which is used to program Java in cell phones, set-top boxes, handhelds, and so on. Java is an object-oriented programming language based on C and C++. However, it is improved and simplified to solve the errors in programming. Java files are converted to bitcode format using a compiler and then executed by the Java interpreter. The whole Java code is run on the Java virtual machine, which provides a runtime environment. Now, the main concepts in Java are its methods and classes. A method is a block of code that performs a task only when it is called. Consider this example. While watching TV, you use the TV remote to change channels. Each button on the remote performs a different task. Methods in Java are the same. We can have methods to add 2 numbers or email a person or to convert kilometers to meters. A group of methods make a class. Classes are used to organize code just like how fruits, vegetables, and clinical products are divided into different sections in a supermarket. There are a lot of features in Java. Let's start by looking at them one by one. It has a simple syntax and is very easy to understand and learn. Java language is robust. It eliminates errors that occur in the C and C++ languages. Java also has features like garbage collectors and exception handling. This makes Java very unique. The most popular feature of Java is that it is platform independent. Here, compilation happens in bytecode, and because of this, Java can run on any machine. It is a very secure language as it contains no virus. Java has a feature of multi-threading. The feature of multi-threading helps Java do multitasking. Java is a portable language as it can run on any platform, and data type sizes are set permanently. So Java program has a fixed size of the code. The last of all, Java is not as fast as C and C++, but provides higher performance than any other language. Now let's see OOPS concepts in Java. Java has 4 concepts: abstraction, encapsulation, inheritance, and polymorphism. In Java, we use objects and classes related to the real world that makes the code easier to make and understand. Abstraction means showing the relevant information that is needed for a task. Encapsulation makes the Java code secure. Data is stored within the classes, and it is not easy to access the data. The next feature is inheritance. As the name suggests, the attributes and characteristics of one class can be inherited by another class. Because of this, coders take less time to create the code. Lastly, we have polymorphism, which means using the same method for different tasks. In Java, we can use the same object or variable in 2 different places where their tasks will differ.
Hello and welcome to Git Commands. My name is Chidanand and I am with the Simplilearn team. Today, I'm going to cover a few essential Git commands and walk you through a demonstration for most of it. I begin by installing a Git Bash or the Git client and configuring it for its first time usage. Once I'm done with configuring the Git client, I'm going to spin up few repositories locally and work on these repositories using Git commands. Once I'm happy with my local changes, I'm going to commit few of them and then push these changes to a Git server of my choice. For today's demonstration, I plan to use github.com, which is a cloud-hosted free service, and it provides free account registrations for anyone. Eventually, I will cover a few topics regarding Git branching and merging, because these two, in my opinion, are the killer features of the Git distributed version control tool. Git is one of the most popular distributed version control tools of recent times, and like any other distributed version control tool, it allows us to perform various version control tasks without really needing a network connection. Before I jump into my demonstration, let me spend some time explaining to you the Git client-server working model. What does it take for a couple of users to collaborate and start working with Git? The bare minimal thing that any user would need in order to start working with Git is something called as Git Bash or the Git client. This comes as an installer for all popular operating systems like Windows, all flavors of Windows, Linux, macOS, and other operating systems. So once you install Git Bash, you get a command line utility using which you can fire up your Git commands and ensure that you can bring up repositories. You can work with these repositories by adding files to it, committing changes to it, and all those Git commands would work perfectly well. So you can bring up a small repository and you can work with your repository using this Git Bash. But what does it take for you to share this repository with another user who has also got Git Bash installed on his system? This is where you would need something called as a Git server. So for user 1 or one user to share his repository with another user, he would need to collaborate using something called as a Git server. So in the present market, there are a bunch of Git servers which are popularly available. Some of them are free. Some of them come with a cost because they are licensed. A bunch of these servers that I can think of are GitHub, which is one of the most popular Git servers that is around in the market for a long time now. It comes with 2 variants. One is the cloud hosted one, which is the github.com. And then the other one is an enterprise server, which comes as a black box that can be installed into your data centers. So typically organizations who don't want their source code to be put up on the cloud would go for this GitHub enterprise servers, wherein they buy these servers and these servers are hosted on their data centers. Other popular variant of the Git server is Bitbucket. This is from the famous Atlassian products and it integrates very well with all other Atlassian products like Jira. In recent times, there's one other variant of the Git server called GitLab, which is getting very popular these days because GitLab not just provides a Git server, it also provides something called as a runner. This is a part of the continuous integration strategy where as soon as you have a source code check-in that is going in, you have this runner that kicks up and builds your particular project. So all these are bundled together in a GitLab. And GitLab also provides you with a community edition which is almost free of cost. Having said that, there are a bunch of these tools available. For my demonstration, what I'm going to do is I've already registered myself on the github.com by providing my username and my password. and I'm going to use a free account. So whatever repositories that I'm going to put up on this server is all public by default. So I want to register myself by using my username or my email ID and my password. So this set of authentication is also referred to as HTTPS authentication. So in order for me to share my repository with, say, user2, the first thing that I got to do is have an access to a Git server where both user1 and user2 are set up. So once I have that, I can push my repository onto this server and provide right kind of access so that user2 or the other developer whoever wishes to collaborate with me on this repository can use his credentials. As long as he's registered properly on the Git server, he can use his credentials and pull down this repository and work with this repository. So this is the HTTPS way of authenticating and sharing repositories. Another popular way of sharing repositories or working with each other is called as SSH authentication. As many of you would know, SSH means nothing but creation of a private and a public key. A bunch of keys, public and private, are created on the client machine. While I create keys, I will be asked for a passphrase. I need to type in a passphrase and remember my passphrase. And then I take this public key and kind of post it onto my account within my Git server, so that whenever I'm going to connect next time using my command prompt or any of the tools, it's going to challenge me for my passphrase. As long as I remember my passphrase correctly, I can authenticate myself and get into this server. So both HTTPS and SSH are popular ways of communicating with the Git server. Having said this, let me just get started by installing the Git Bash on my local system and then fire up some of these Git commands and build up some repositories, make some changes in my repository, commit these changes, and later use my GitHub credential to connect to my GitHub server and push my repositories out there. Let me now go ahead and find my Git Bash for my Windows so that I can go ahead and install it. So I just type in Git client for Windows, open up a browser and type in for this. The first one that I find is a GUI tool. I don't need this GUI client, I need this one. So this is the Git client or the Git Bash that I was referring to. It's about 40 megs, and let me just download this. Pause this video for some time so that the download happens and come back to you once I have the download. The download seems to be complete. When I'm recording this video, the version that I have, the latest version that is there is 2.19.0, and this is a 64-bit version for Windows. So I've got that downloaded. Let me go ahead and find it and install this exe. All right, I go ahead choosing all the default options. I want it to be installed in C: program files under the Git folder. Everything looks good for me. I'm not going to make any changes here. Git Bash from Windows. Yes, I may want to use Git from Windows command prompt. That sounds good for me. Open SSH, that's fine. Looks good. Looks good. No, I don't want any of these new features. So what I'm doing is installing the Git Bash or the Git client so that I can start using my Git commands. And the version that I'm using is 2.19.0, which, as I record this video, this happens to be the latest version. All right, so looks good. I don't want to see the release notes. I'll say launch Git Bash. So what I get is this window. So this is the Git command prompt. So let me check if everything is looking good. Say Git version, it sounds good. Say Git help. All right, a lot of Git help commands. Everything looks good. So I ended up installing the Git Bash. I can go ahead with all other commands. Now that I have Git Bash installed on my system, let me open up a Git Bash prompt and start using it. But before I do anything, I just need to configure it for the first time, stating what would be the username and the email ID with which I want the Git Bash to be configured with. The command to do that is git config -- global, which means that this setting that I'm going to set would be a global setting. User.name, and the name of the user would need to be specified within a double quote. In my case, I am using a Simplilearn account, which is the official account, and this is the particular username of this account. The other setting is nothing but git config -- global. This is also a global setting, and this would be the email ID. the email ID need not contain a double quote. So in my case, this is the email ID that I would be setting up Git to work with. All right, let me check if the configurations were set correctly or not. All right, if you see this, the username and the email ID has been picked up the way I wanted it to be picked up. Looks good so far. All right, so what do we do next? By default, whenever you open up the Git prompt, you're placed into your home directory. Let me create a folder here, which would be a repository folder from where I'm going to create all my multiple Git repositories. So I will create a folder called, let's say, git_demo. All right, there's already a folder called git demo. So let me just delete that in the first place and let me create this git demo again. All right, let me navigate to this particular folder. So this is the folder. Let me open up that folder using a command prompt. This is my git demo. So this would be a folder. So I would use this folder as a base folder for creating all other repositories as a part of this demo. So let me create my first repository. A repository is nothing but a folder. So let me create my first folder called first repo. And let me get into this repo. All right, as of now, this is just an empty folder. If at all I navigate to this, you would see that this folder is empty. There's nothing much in this folder at all at this moment. Okay, so let me create a repository out of this. How do I create a repository of this? It's pretty simple. I just run a git init command. When I say git init, it means it's going to initialize a repository. As of now, the folder contained nothing in it. It was an empty repository. So it initializes an empty repository in this particular folder. If at all I look at my content, you would see that there's a hidden folder. This would be a hidden folder since I've configured my Explorer to view all hidden folders. I see it, otherwise you wouldn't see it. So a folder by name .git is created within this first repo. And this was created because we ran the command git init. If I get into this folder, I see a bunch of directories and other configurations. If you see, there's something called as a hooks directory, a couple of configuration files that are here in this directory. All these relate to one or the other type of a client hook that can be enabled. And there's info, there's objects, there's references, a bunch of stuff that is there. So what is this folder? This is a magical Git folder, and this is created whenever a repository is initialized. So by default, if at all you get into any Git folder or any Git repository, you would see this .git folder. A word of caution, do not get into this folder and try to modify anything, because if you fiddle around with this and corrupt this particular folder, your whole repository will go for a toss. So let me come out of this and let me show you another thing. Now, if you notice here, when I was in the folder, the repository did not have anything after this. Now, when I say git init, there is something called as a master that shows up. So typically what happens is whenever a Git repository is created for the first time, it creates a default branch. The name of the branch is called master. And that is why you would see master within braces. This doesn't mean anything else other than we have a repository out in this particular folder. And by default, there is a branch called master and we are currently on that branch. If at all I create multiple branches in this folder, whenever I navigate to different branches, the branch name within these brackets would change. All right, so far so good. So we created a folder, we made it a Git repository by initializing that with a git init, and then I've not put anything yet in the repository. So let me try to do that. Let me create a few files within this particular repository. So I use a touch command. Touch is a Linux command. It kind of creates this particular folder. If at all you're not comfortable with the file creation by this way, you can always use a file explorer and create some files in this. So I create a file called touchmaster.txt. I'll open up in the notepad. Okay, so this is my first file. That's what I'm going to write inside this. I save this and I come out of this. All right, now let me do a git status command. So what does this tell you? There's no commit set, you're in the master branch, there is an untracked file, and this shows up in red. It also gives you all the commands that is supposed to be run. So if at all you want to add this file, you would say git add and the name of the file, and then you're going to commit it. So what happened is that when the repository was initialized, it was an empty repository. Now that a Git notices that there is a new file in this repository called master.txt. If at all you want us to let Git know that you want to track this file, we need to add this to the repository. So the command to add that is called git add. I can specify either the name of the file or I can give a wild character saying git add dot. Now if I run the git status command again, it says there's no commits yet. Added a file, and the file which was earlier in red now shows up in green, and it says it's a new file, master.txt. All right, it also gives you something called Git Remove command if at all you want to unstage or undo your changes. So what has happened is the file which was earlier untracked is been added into the Git index, or it is ready for staging, or it's in a staged state. Now I can go ahead and commit this file if at all that's what I want to do. So let me do that. I'll do a git commit -m and I give a message that I want. I would say this is my first git commit. All right, I run the git status command again and see it says on the branch master, nothing to commit. It's all nice and clean. So typically what happened was I created an empty directory, made it into a git folder by doing a git init. I put a file into it. I made some changes to the file. I added that file into the repository and I committed to the repository. If at all I run the git log command, it says this was the commit ID or the commit number or the commit hashtag, and this is the author. If you notice, this is the email ID and the username that we set earlier. And this was done on this date, and this is the commit message that is there. All of it looks so good. Let me do one more commit into this repository. So I will touch master1.txt. I'll put in another file. I'll open up this particular file, write something into this. All right, I save this change. Let me also open up the older file, make some more change into this. All right, so what I did, I modified the older file that existed. I also added a new file to my repository. Now, if I run the git status command, it says modified this file, which is showing in red, and it says you have one more file, which was an untracked file. All right, now let me add both these files because these are the changes that I want to incorporate. I would say git add dot. I run the git status command again, and it says now this is a modified file, this is a new file. Looks good to me. Let me go ahead and commit this. So git commit with a message that says this is my second commit. All right, if I do a git log now, it shows both the commits. The first commit is the one that shows up at the bottom, and the topmost one is the latest commit that is there. So far, so good. If at all you notice, I'm doing all these git commands without really connecting it to any git server. I don't need any network connection for doing any of these things. I can keep on doing more and more git commands and run git commands the way I want to without really having any connections to the git server. Now that I have my changes the way I wanted, and I've checked in all the code changes into my local repository, I may want to share my repository with somebody else and work in a collaborative way. So the way to do that is, as I mentioned earlier, to host this repository or to push this repository onto a Git server. I already have a GitHub account wherein I've registered myself using my username and password. So I log into my GitHub account using my username and credentials, and let me go ahead and create a new repository. My repository is already there on the local system, so what I essentially need is just a placeholder for my repository so that I can link them together and push the content from my local repository to the server. If you notice, the name of my repository is this first repo. So let me copy this. I would create a folder structure or a repository structure on the server with the same name so that when I pushed my repository from my local box, it will go ahead and get created in the server. So the repository name should be the same as what I created on my local box. Description I would say this is my first GitHub repository on the server. This is just an optional description that will show up. And if you notice, I can't have any private repositories. So whatever repositories that I'm going to create here would be a public repository. So I choose public, and I don't want to initialize this with a README file or anything of that, because I already have a repository with some content, with some code checked in. All that I need is a placeholder for my repository on the server. So with this option, with just the name and with an optional description and the repository being public, I go ahead and click on the Create Repository button. So if you notice, it gives me a bunch of commands that I would need to run in order to create a repository and push it onto the server. And also, important point, it shows me two URLs. One is the HTTPS URL and the other one is the SSH URL. As of now, we do not have any SSH keys that is set up. So let me use this HTTPS URL to connect my local repository with the repository on the server. So I've done all these things. I already have the repository set up. All that I need is a placeholder for me to connect my local repository with the server URL. So this would be the command that I need to copy, which essentially links or adds an origin with the URL of the Git server. I just copy this command and run it here. Git Remote Add. The name of the remote is called origin, and it points to an HTTPS URL, which is nothing but the placeholder that I've created on the server. All right, so let me check if it's added correctly. Okay, the URL looks good. I'm all set. I've got 2 commits in my repository. I'm done with all the changes. So let me try to push my repository onto the server. The command for doing it for the first time is git push -u. This is for linking the upstream origin master. So git push -u upstream linking origin master. Link the master branch of my local repository with the master branch on the server repository. And where is it going to push? It is going to push by default to an origin, and the origin points to this URL. All right, let me try doing this. So it essentially opens up an URL asking me the credentials with which I need to log into my GitHub server. So let me just copy and paste the username and the password with which I have registered. I would say login. Okay, success. So I'm able to create a repository on the server, and the content seems to be pushed, and it created a new branch called master. It has linked the master branch from the local repository with the master branch on the server. So let me go back to my server and refresh this page and see if all my commits have come in. master1.txt. If at all I see the commits, there seem to be 2 commits. This is my first commit, this is my second commit. And if at all you notice, each of this commit comes with a hash key or a hash ID, which contains the details of my commits. In this commit, the files were added. This was the line that was added. If you look at the second commit, I added these lines. I made this, one line chain that was there. I also added this new file which was not existing. These are the 2 commits that existed. And if you see the timestamp of the commit, this is the commit which was committed 15 minutes ago. So what does this mean is that the commit is the timestamp when we actually committed the code in the client. The pushing is just after we have committed the change, we have pushed it. So there's no timestamp of the push that happened. This completes the first part of the tutorial, wherein I created a repository on the client and then I pushed it to the server after creating a repository skeleton on the server. Now let me demonstrate to you the SSH configuration that is required for creating a pair of SSH keys and ensuring that I connect to the GitHub server using the SSH mechanism. So for doing that, I need to first create a pair of private and public key. The command to do that is ssh keygen -t. I will use the RSA mechanism for creating my keys, capital C, and I need to specify the email ID using which I'm going to connect to, or I need to create the keys for. Alright, so generating a private and public key pair, it says, let me know what folder should I create the keys in. So by default, the keys are created in the user home directory under a .ssh folder. So this is pretty good for me. So let me go ahead and say that, that's fine. Enter a passphrase. So let me enter some passphrase. Keep in mind that I would need to remember my passphrase because when I'm going to authenticate myself using SSH mechanism, it will challenge me for this particular passphrase. I need to enter the right passphrase so that I get authenticated. So the key is generated and by default it is created in this particular folder. So let me go over to that particular folder. And this is the folder where the keys is generated. You would see a public key and a private key that is created. Let me open up the public key with a notepad and then copy the contents of the whole file. And now I would need to stick it in on the server so that I can get myself authenticated using SSH keys. So I've logged in to GitHub using my credentials and go to my settings. And you would see an SSH and GPG keys. Let me click on that. As of now, there are no SSH key or GPG keys. So I will click on new SSH key and let me paste my public key that I've copied. And I would say add SSH key. It prompts me for my password just to make sure that I've got the right kind of authentication to be adding a new key. So this one looks good. That means the keys were added successfully. Let me check if my SSH keys are working well. So I do SSH -T. I would say git at github.com. This is just to double check if my SSH keys are authenticated correctly. Are you sure you want a connection? Yes. You want to continue? Yes. All right. Now a check for my passphrase. Let me enter my passphrase. I hope I remember it correctly. All right. Pretty good. I've been successfully authenticated. So that means now my SSH keys are good. And just by using my passphrase, I can connect to my GitHub server using SSH. All right. So for the second use case, what I would do is create a repository on the server with some content in it and then clone that repository. Cloning is nothing but making a copy of that repository, linking the origin so that I create an exact replica of the repository which is there on the server on my local drive. So let me first create a repository on the server. I will create a new repository. Let me give a name for my repository and let me kind of initialize that with the README file. I would call this my second repo. Give some description. This is my second repo that is created straight on the Git server, on the GitHub server to be precise. It's a public repository. This time I'm going to choose this option. The reason being that I don't want to create just a skeleton as of now. I want to create a repository with some README file in it. A random README file with no content in it, but then I want a repository to be created on the server. All right, I say create a repository. So a random README file with some content in it gets created and I can see there are two URLs to this repository, HTTPS and SSH. So this time, let me copy the SSH URL so that I will use this URL to clone this repository on the server, rather from the server to my local box. All right, so let me navigate to my root folder, the folder that I created for making all my repositories, Git repositories. If you see, my first repository is already here. So let me clone my repository, the second repo that I created on the server. The command to do that is git clone the URL of the repository that I want to clone. Oops, looks like I didn't copy the URL correctly. Let me copy that again. Copy this URL. All right. So if you notice, there is no HTTPS to it. I'm just cloning the URL that is SSH URL of the repository. It asks for my passphrase again. Okay, so I just had first repository earlier. Now I have something called a second repo. This is an exact replica of whatever was the repository content that was created on the server. So if I get into the repository, there's just a simple readme file that is there. Let me try to add a new file out here. I would say notepad, second.txt, some text file I'm going to put in here. Yes, definitely you will not find that file there. This is my second file that I will push onto the server. I'm going to put in some content out there. I'm going to save this. And if I do git status, it says this is a new untracked file. Do you want to add this file onto the repository? Do you want to track this file? Yes, I definitely want to track this file. Let me also commit my change to the file with a message. This is my first commit for the second repo. I give in some particular message. And this time around, since I cloned my repository from a server, the origin is already set for me. I don't really need to add the origin and all that stuff, because what happened in the first case was that I was creating a repository from my local box and then pushing it on the server, which is why I had to set up the upstream branches and stuff like that. In this case, I have cloned an existing repository from the server. So when I clone, I get the replica along with all references to my repository. So I don't need to do anything more other than push the content. I would just say git push. To be on the safer side, I would say origin and master. It asks me for the passphrase. Okay, it pushed the content onto the server. Let me see if the contents have come in here. Okay, wonderful. I had only one commit. Now I see my second commit. So what was added as a part of the second commit? It says a new file was added. All this line that never existed got added. This is the second file, the content exactly what I pushed onto the server. Now this completes the tutorial when I created a repository on the server, cloned it, made some changes to the repository and pushed it to the server using SSH. A quick recap of all the Git commands that we ran till now. Git init is used to initialize a repository. So if at all you're creating a local repository, you can get into any of the folder which is not a Git repository and run this command. Whenever you run this command, a magical folder by name .git gets created in the folder, and from that time onwards, Git will start tracking any changes that happen to that particular folder. It also creates a new repository and a branch. By default, the branch that is created is called the master branch. Git add dot is a wildcard character for adding any number of new files into your Git repository. If you have a bunch of files, 1 file, 2 file, 10 files, a folder containing multiple files in it, all of them could be added into the repository using this command. So once you add any number of files into the repository, you can keep on adding more and more files into the repository. Once you're done with that, you want to commit the changes that has happened in the repository, you use the git commit command. Git commit -m with a meaningful message. This will commit all the work items that you've done in terms of the files that got changed, the files that got added, all this with one particular message. Git status will give you the status of all the files and folders, any file that got added, any file that got created, any file that was deleted, all the status of the files will be obtained using the git status command. Git log will show you all the commit history with the latest history or the latest commit showing up on top. Git add remote origin. This command is used whenever you want to link any local repository to a server. And this is when you want to really push a repository from the local to the server for the first time. Git push -u origin and master. This is the command that you would use whenever you want to push contents from the local repository to the server. Git clone and the URL of the server. This is the command that you would run whenever you have an existing repository on the server and you want to make a fresh clone or a fresh copy of that particular repository onto your local box. More than often, many developers or Git users find themselves in situations where they would want to go back in history and modify or change some of the files that they recently committed or checked into the repository. Now, from a perspective of Git, this is a very simple activity. However, from a perspective of version control tool, you will have to be really cautious about the change that you're going to do. In case the changes are pretty local, none of the developers or none of the other users who are collaborating with you would be affected by this change. You're good to go ahead and make this change. However, if your repository is being pushed to the server and you're trying to modify something from history, this would have a very bad or adverse effect on all the other users who will be using it. You need to be really cautious while running these commands. In case your repository contents are local, you've not pushed your changes to your repository, and if at all you made some changes to the repository, maybe to fix a defect or to include a new feature, and you missed few things, you can go ahead and modify this with some of these commands. Let's say I have this simple repository called undo repo, and if at all I look at the logs of these, I have the commit histories which are like this. I have about 5 commits that is there in my repository, and in C1 I've added a file, in C2 I've added another file, in C3 I've also added some file, in C4 I've made some changes to M1 and M3, and in C5 I've added another file called M4. Now this is my commit history. Now let's say I made these 2 commits, but possibly I want to club them together along with some other changes because whatever changes I did not really fix things the way I expected it to fix. So there is a Git command called Git Reset. This would allow me to go back in history, to go back to any of the snapshot, get rid of all this commit history or the commit messages, but retain the changes that were made as a part of these commits. So if at all I need to go back in history and go back to this particular commit, and however, I just want to get rid of these commits that are there in terms of the commit messages, but I want the changes that were there as a part of these commits to still exist. I would do command called git reset -- soft. Now this would go back or unwind my changes back to this particular snapshot, getting rid of all the commit messages that were there as a part of these 2 commits, but a soft would ensure that the file changes that were done as a part of these 2 commits would still exist or full remain. So the command for that is git reset -- soft, which is the snapshot that I want to get back to. If this is the commit that I want to get back to, I just copy this and I paste this. Alright, it doesn't give me any message, but if at all I do a git log pretty one line, what it says is C1, C2, now the head, which is nothing but the current pointer, which was earlier pointing to C5, it's gone back to C3. Now what happened to the changes that were there as a part of C4 and C5? If at all you do a git status, if you see the changes that were a part of C4 was some changes to M1 and M2, and C5, a new file got M4 got added. If at all I do a git status, you would see those changes still exist. However, from the git history or the git commit history, C3 is the topmost commit that exists as of now. C4 and C5 have been gotten rid of, but the changes that were there still exist. Alright, now I can make some more changes that I want if as a part of my commit and possibly go ahead and commit this whole thing as a new commit altogether. Maybe I'll open up a notepad and possibly create a new file called m6.txt and say one new file that was missed out. I make this change. I go to a git status. All these files are still there. I would say git add dot. I would say git commit -m C4 rewriting history, and I do a git log pretty. There you go. So C1, C2, C3 still existed, and whatever was a part of C4 and C5, the older ones, I've gotten rid of this. Along with those old changes, I also added a new file. I made some changes and I was able to commit it. Now if you look at my git history, it's all nice and clean. However, do this activity only when you don't push your git repository to the server. One other most powerful and useful command while undoing or resetting the history is something called as revert. This is a safe way of undoing some things. Remember what I talked about when exactly you can do a reset? It's only when your changes are local and is not being pushed to the repository. take this scenario wherein, let's say I have a Git server and I have the changes which are C1, C2, C3, and possibly C4. Alright, so this is a bunch of commits that has happened. This was the oldest commit and this is the newest commit. And if at all developer 1 is the one who's responsible for pushing these contents in the first place. So he has got C1 to C4 on his history. I'm going to jump all these C2 and C3 and get into C4, and he's pushed all these contents out here. And there are a bunch of people from the server who has pulled this repository, and all of them are at the same level. Now imagine a use case where developer 1 then figures out that by mistake he put in the C3, which was the wrong thing to do, and possibly he could have done a better job of fixing this in a different way. So he wants to get rid of the C3 or C4 or any one of these commits. If he's going to do that and push it to the server, first of all, the Git server would not allow him to go back in history. But assuming that he forcibly pushed something, what would happen to all these people who are looking to work ahead from C4? All of them would be affected in an adverse way. So in short, never go back in history. If at all you need to undo something, go ahead and put in a new commit to undo something. Let's take this example. Maybe if at all a developer 1 wants to get rid of C3, better way to do that is by adding a new commit which is ahead, say let's say C5. And what does this commit do? This commit possibly gets rid of C3. Instead of going back in history, it actually is taking your Git history ahead. But as a part of this commit, you're undoing some part of the work that was done as a part of C3. In short, you're removing a commit, but to remove a commit, you're adding a new commit. And this is why you're doing it, because there are a bunch of other people you're using this repository collaboratively and who are planning to get ahead in terms of history. They cannot afford to go back in history and modify something in history. All right, the command to do this is called the Git Revert Command. So let me take up this repository, which has got a bunch of commits in it. And if at all I do a git log, pretty one line, I have these bunch of commits. In C1, I've added a file. In C2, I've added another file. In C3, I've added one more file. And in C4, I made some changes. And this is the latest commit, and this is the oldest commit. So if at all I see the contents of the Git folder, it contains M1, M2, M3, and M4. And let's say, looking at the previous use case that I mentioned, I may want to get rid of this particular commit. I want to get rid of the C3, which is nothing but I've added a file called m3.txt, but I added it by mistake. I need a better way of fixing it. Possibly I'll look at it later on, but for now, I don't want this particular commit and the changes that were made as a part of that commit to exist. So the better way to do that is using the Git Revert command. So Git Revert and the commit ID, whatever I want to revert. So if I want to revert this, I copy this particular commit ID, and bear in mind that considering a reset, revert works on one commit at a time. So I can do one commit revert at a time. I can club a bunch of them together and do one commit, but otherwise the revert always works on one commit at a time. So git revert, paste this. Essentially what I'm trying to do, I'm trying to undo this particular commit. While I'm undoing this commit, what does Git do? It safely adds a new commit, and a part of this new commit, it undoes whatever changes that were done as a part of this commit. So if I say git revert this, all right, I forgot to mention a message, which is why this window is showing up, but that message is good for me. I say write and quit. All right, and if I do a git log, all right, if you see this, C1 still is there in history, and our history is going ahead from C5. I see another commit, but what was there as a part of this commit actually is getting rid of this commit C3. So if at all I see my files here, there's only M1, M2, and M4. M3 was added as a part of C3. Now I've gotten rid of M3 by getting rid of the revert command for C3. So this is a better way of undoing things. Now that we have acquainted ourselves with few of those basic Git commands, let me get into a very interesting topic regarding Git, which is about branching. The topic is interesting because Git deals with branches in a completely different way compared to any other version control tool. In most of the version control tools, whenever you create a new branch, a complete copy or a subset of the whole repository is created, which in my opinion is very cost inefficient because it's a very expensive operation both in terms of time and the disk space. However, in Git, you just create a very lightweight movable pointer whenever you create a branch. There is no folder or no copy of the repository that is created. In short, the branches are very inexpensive in Git. So go ahead and create any number of branches that you need. However, once you create your branches, do all the work relating to that branch in that specific branch. And once you've completed your task, go ahead and merge your branches back into your base branch and then delete the branch. Let me go ahead and create a repository with some branches in this and give you a demonstration of that. So let me go back to my base directory, which is Git demo, and then I'm going to create a new folder here. I'll create a folder called org details. Alright, this is my folder here. Alright, I navigate into this folder and let me create a repository here. I initialize a repository and .git folder is created without any files in it. So let me create a few files in it. Say notepad name.txt. Organization name. I create a name.txt within this. Maybe I'll create one more file in this. Notepad employees.txt. Simplilearn has over 3K employees. I just put in some content in this. Save this content. Alright. So if at all I do a git status, I just see two files in it. So let me go ahead and add these two files and let me commit my changes. So git commit -am or -m. First commit. So if I do a git log, I see only one commit and there are two files here. You can see those two files that is here. Alright. So at this stage, let me go ahead and create a new branch. And the command for creating a new branch is git branch name of the branch. So let me name my branch as Bangalore branch, BLR branch. And this created a branch. But I don't see any changes in the folder structure or in the file that exists here. I've just created this branch. So if at all I do a git branch, I see these two branches. And whatever star means I'm currently in this master branch. So let me go ahead and get into the BLR branch. At this moment, the number of files that exist in this repository is same. There's absolutely no change in any of the branches. Both master and BLR branch point to the same snapshot. So let me get into the other branch, and the command to do that is git checkout BLR branch. Now I actually switched into Bangalore branch. If you see the content of the files, there's exactly two files the way it was earlier. Because I've created a branch from my base branch, which is the master branch. And when I created a branch, there were two files existing here. If you see the content of these files, they would all be the same. Alright, so let me create a file that is specific to Bangalore branch. So I would just say notepad. Maybe I want to put down the address of this organization specific to Bangalore in this address.txt. So I say notepad address.txt. I'll say Simplilearn Bangalore office. Say located in some address. I would say Bangalore. That is the content of this file. And I'm creating all this new file in this BLR branch. So I would say git add dot, and I would say git commit -m Bangalore branch commit. Alright, if you see this, now I have an address.txt which is there only in the Bangalore branch that I'm presently on. Now let me switch back to my master branch. The command to do that is git checkout master branch. If you remember, when I forked out or when I created a new branch from the master branch, I didn't have this address.txt in it. So let me go back to git checkout master branch and keep noticing this particular. What happened to the address.txt? It kind of disappeared. Now, how did that happen? It's all because of this magical Git folder. So what happened is, now Git knows that when you are in the master branch, the file that was there in the Bangalore branch, which was called the address.txt, didn't exist. So Git is playing around with the file system snapshot. So if I come back, let's say I come back to git checkout Bangalore branch. If you see this, the address.txt file appears. So this particular file is only present in the branch, and Git is playing around with the file system snapshot by moving the pointers across and ensuring that whenever I'm switching to Bangalore branch, I see this address.txt. When I go back to my master branch, I don't see this Bangalore branch contents, which is the address.txt. Alright, now that I created this branch, maybe I may need to push this onto the server. So let me go ahead and create a particular repository structure on the server, similar to whatever we did in our previous exercise. So the name of the folder needs to be exactly this one. So let me copy this and let me create a repository very quickly. I'll go here and say new repository. All right, this is the name of the repository, git branch demo. This is what I'm going to put in as a description. I would say public. I don't want any readme files in it because I already have a repository. I would just say create a repository. All right, let me use the SSH URL. Yeah, this is the SSH URL. This is good for me. So let me copy this URL. Let me add it here. I'm linking my local repository with the server, and let me come back to my master branch. Let me first push my master branch. So I would say git push -u origin master. It asks for my passphrase. All right, I pushed my master branch. It looks good. It says new branch master is created. So if I go back to my server and I do a refresh, if you see, it says only one branch, and it says what is the name of the branch, master. If you see the contents, there is employees.txt and name.txt. Now let's try to push the other branch that is there. The command to do that is a little different compared to the way we created it on the client, because on the client we created the branch with a git branch command. Now this branch doesn't exist on the server, and I need to push this new branch onto the server. So the command would be git push -u origin and the name of the branch that I want to specifically push. All right, now it created a branch out here. Let me do a refresh of this. All right, it says 2 branches. If I get into this Bangalore branch, I would see the address.txt. If at all I go back into master branch, I would not see this address.txt. Wonderful. Now let me do one thing. Let me try to get the changes from the branch that I created back into the master branch. That is what I would mean by merging. I would want the changes that is there as a part of the Bangalore branch to come back into my master branch. So if I go to git checkout Bangalore branch. I see this address.txt. This is there only as a part of Bangalore branch. Now, assuming that I'm done with the changes from the Bangalore branch, I want to get those changes back into my master. So let me come back to my master branch. And the way to merge in the changes is git merge. So what is it that you want to merge? I want to merge the Bangalore branch changes. And where will it merge? It will merge it into the current branch that I'm on. Presently, I'm in the master branch. So this command would merge the changes from the Bangalore branch into your master branch. So with this, if you'll keep looking here, the content that was there that was added as a part of Bangalore branch, which is nothing but the address.txt, this file should appear as soon as we do a merge. All right, so it happened quickly, and you would see this address.txt that is here. So if you see, let's check the contents in terms of the git log. All right, so there was only one branch that we had earlier, which had only one commit. Right now, we are at this Bangalore branch commit, which was there as a part of the Bangalore branch commit. So with this change, let me push this change onto the server as well. Git push origin master. Okay, those changes were pushed to the server. And now, if at all I do a refresh out here, okay, I'm in two branches. The branches is master. Even if I'm in master branch, I should see this address.txt that is there. Even if I'm in the Bangalore branch, the content is all same because we have merged these two branches. Now that I've merged this branch, I don't need this branch anymore. So I would go ahead and delete this locally as well as push it onto the server so that it gets deleted from the server as well. So delete branch locally. The command is git branch -d and the name of the branch. Only thing you need to ensure is that you should not be currently on that branch which you're trying to delete. So I would say git branch, and I'm presently in the master branch, so I can go ahead and delete the other branch. So git branch -d Bangalore branch. All right, this got rid of our Bangalore branch locally. If at all I do a git branch -v, it shows there's only one branch as of now. However, this branch would still exist on the server because server doesn't know anything about the changes that we have done. We need to specifically push our changes onto the server. Okay, there are two branches still here. So let me go ahead and push these changes so that the branch gets deleted from the server as well. The command to do that is git push origin -delete and the name of the branch. All right, so this went ahead and deleted the branch from the server. Let's check that. Okay, if you see now, there's only one branch. These are the basic steps that you would need to know before you work with any of the branches within Git. And as I said before, the branches are very, very inexpensive in Git. Go ahead and create any number of branches that you want, but just ensure that once you create your branch, finish off your task, and once you finish off your task, go ahead and delete the branch. And before you delete the branch, please ensure that you merge in the branches so that you get in or take in the work that was done as a part of that particular branch. To summarize, the Git branching commands are as follows. To create a new branch, you issue a command git branch, the name of the branch, and this would automatically spin off or create a new branch from the existing branch from where you issue this command. If you are on the master branch and if you execute this command git branch new underscore branch, it creates a new underscore branch from the master branch. Once you create a new branch, in order to get into this branch, you would type in git check out the name of the branch. This would automatically switch the file system snapshot between different branches. Now the branches that are created are by default created on the local repository. In case you want to push any specific branch onto the server, you would have to issue a command git push -u origin and the name of the branch. So this will ensure that the contents of the new branch are pushed onto the server. At any time, if you want to list out all existing branches on your local repositories, the command would be git branch -av. Assuming that you did all your work in a new branch and you're happy with the changes, you would want to bring back those changes into the master branch. The command to merge the contents of any new branch into a master branch would be git merge and the name of the branch. And this would automatically merge the branch contents that you specified into the branch on which you currently reside. If at all you're on the master branch, and if you issue a command git merge new underscore branch, this would merge the contents of the new branch onto the master branch. So once you merge the contents of any branch, you would possibly want to go ahead and delete this branch. So the command to delete those branch locally is git branch -D and the name of the branch. This again would delete the branch locally. In order to make this change on the server, which is in order to remove this branch from the server, the command to do that is git push origin -delete and the name of the branch. This would also delete the branch that you created on the server.
Hello guys, this is Vikesh. So when we talk about Java, it is one of the most popular programming language out there, and it was created way back in 1991, but it was publicly released only in 1995. It was developed by one of the famous developers of our generation, who is James Gosling at Sun Microsystems. And then later Java was acquired by Oracle, and today Oracle owns Java. Java is very simple and easy to use, and we will look at different aspects of how it is easy and simple to use. It's a write once, run anywhere type of programming language. Again, we will look at details into this particular concept as well. And when we talk about the usage of Java, you can use it to build web applications, mobile applications, desktop applications, even command line applications. And at the same time, you can also use it to build complex applications like gaming applications, building microservices, or building distributed computing, etc. Let's talk about the features of Java. So one of the most prominent features of Java is that it's an object-oriented programming language, which means that everything which happens in Java happens around objects. Objects enable the execution of the program. Objects talk to each other to exchange data and messages. We will look at the concept of objects in details in the upcoming lectures. It's a platform-independent language, which means that, again, going back to the previous point of write once, run anywhere, it basically enables the program to be run on any platform once compiled. So once you have prepared your program and you have compiled your program, then your compiled program can be run on any platform. It is a strong type checking language, which means that it will force you to respect the contracts of the variables to the data types. For example, if you have created a collection which should accept strings, then you can only insert strings in that collection, and it will not allow you to add a number or an integer into that collection. So it's a strongly type checking language. So when you run your program, it's a two-step process in Java. You compile the program and then you execute the program, which we also call as interpretation. So you have a Java compiler and you have a Java interpreter. You first compile your program and then you run the program using the help of Java interpreter. Java also provides automatic garbage collection. It's a really important feature. And if you talk about the languages prior to Java, like C or C++, they did not offer this capability. And this capability made Java really popular because it could automatically find the unused objects and variables and remove them from the memory to free up memory space for the program execution. It also provides multi-threading support, which means that you can build multi-threading applications like a gaming application. If you take the example of a racing game, for example, so there can be one thread which is monitoring your leaderboard score. There can be another thread which is displaying the speed of the car. There can be another thread which is displaying the graphic. There can be another thread which is displaying the sound. So you see all of these threads are working parallelly, and Java provides the support to create such applications using the multi-threading capability it has. Java is secure by default because there are no pointers in Java. So there are no possibilities of having any memory leaks or any reference leaks from the application. Again, if you take the example of programming languages like C or C++, you had the concept of pointers. and we witnessed a lot of scenarios and a lot of incidents where there was a memory leakage happening in the production application, which was really a bad experience for the organizations. So Java removed the concept of pointers totally from its programming language. It's also a very robust language because it provides a really great exception handling framework out of the box, which developers can use and implement to build really resilient applications. So now let us understand how a Java program is run. So at first you basically write your Java program and you store your Java program into a .java file. Then you compile your Java file with the help of the Java compiler. Once the program is compiled, the compiler is going to generate another file, which is a .class file. And this .class file is basically the compiled file, or also known as the bytecode file. So this bytecode or the .class file code can be run on any platform, be it a Linux platform or a Windows platform or a macOS platform or any other platform. To give you some more context, the first two steps where you write your Java program and you compile your Java program can be run on any machine. Let's take the example that you ran these two steps on a Windows machine. So you write your program and you compile your program on a Windows machine, which generated a .class file. Then you transported this .class file to a Linux machine and it also worked there. You transported your .class file to a macOS machine and it worked there as well. And that's what brings the platform independence concept of Java, that you can write the program once on any platform, and once you have the bytecode available, then you can run this program on any other platform of your choice. Okay, so that was about how the Java program execution works and how the platform independence is actually achieved. Now let us spend some time to understand the anatomy of Java. So once you download Java and install Java on your local machine, you will hear the term JDK. Actually, we'll see that in the next lecture, that when you try to download the Java, it will say JDK download. JDK stands for Java Development Kit. So the Java Development Kit is the installation of the Java. This is what you're going to install on your machine. Once the JDK or Java Development Kit has been installed, the JDK will provide a lot of other components as well, like Java Runtime Environment or JRE, Java Virtual Machine or JVM, some class libraries, and some other supporting libraries. So let us understand what happens when your program is run and how these components work together to make sure that your program runs as expected. Let's start from here. So you install JDK or the Java Development Kit, you write your program, and then you compile your program with the help of Java compiler, which is provided by JDK. Once the program is compiled, your .class file will be generated, and then you can run that .class file using JRE. In fact, if you just run your program on your local machine, JRE will automatically kick in and run your .class file. So the Java Runtime Environment or JRE runs your .class file with the help of these three components. Let's talk about first component, which is Java Virtual Machine or JVM. So the Java Virtual Machine is actually the virtual environment inside which your program runs. This is the real main environment inside your .class file is running. So when this program is running, how does it achieve this environment? For achieving this virtual machine environment, it would need some runtime libraries, and that is provided by these class libraries. For example, there would be a runtime jar or rt.jar as a shorthand, which will be supplied to the program at the runtime to make sure that the program runs smoothly. Then there are other supporting libraries as well, which your program may be using. For example, if this .class file is, let's say, a calculator program, then it might be using a square root function from java.math package. So how does the java.math package get supplied at runtime? It would be supplied by the other supporting libraries which are present inside JRE. So JRE will make sure that your program runs inside the Java virtual machine. It gets the required runtime libraries, and it also gets the libraries which are referred in your program at runtime. And this all together will make sure that your program is running. So you can see JDK basically provides GRE automatically and JVM automatically, but you can also install GRE separately. If you talk about that use case where you compile your program on a Windows machine using JDK, and then you exported your .class file to another machine, and there you just install the GRE. You don't install JDK there, you just install the runtime environment, and you can run the .class file just using the runtime environment. Let's get started with inheritance. So inheritance is basically one of the most important properties of any object-oriented programming language. It's basically a concept, and the concept says that what if you have a scenario where you want multiple classes to share similar behavior and similar properties. Let's understand this with the help of an example. Let's take the example of a bank. When you go to a bank to open an account, there are multiple types of accounts. There can be a savings account. It can be a type of current account. There can also be a different offering for personal account and commercial accounts, such as for businesses. Then you may also have loan accounts, which are having different kind of properties. So all of these types of accounts are still technically accounts, and they will share some similar properties. For example, all of them will have to maintain some sort of an interest rate, for example. All of them will be used to either deposit money or withdraw money. So there would be some kind of similarity across all of these types of account classes. But at the same time, there will also be some sort of differentiality amongst these classes. The way you will calculate the interest rate for a current account will be different from the way you will calculate the interest rate for a savings account. And the same applies for commercial account, personal account, loan account, etc. So you see that we have some common behavior, but at the same time, we also have some different behavior. So whenever you have such scenario, always think about applying the concept of inheritance in your application. There's another simple way to spot whether inheritance can be used at a particular place or not. Inheritance is also called is-a relationship. So whenever you read the requirements from a customer, just try to find the words which use this particular phrase is a. For example, car is a vehicle. Savings account is a type of account. Similarly, you will find many other types of similar examples. So whenever you will see that is a relationship between two different kinds of objects or two different kind of entities, that means that there might be an inheritance relationship being applied between them. And that's how you will spot the usage of inheritance. So far we have understood this concept that there would be some sort of relationship between the two classes. What will be this relationship? The relationship will be of parent-child type. There will be a parent class. Some people also call that as base class. And then there will be a child class. So the child class will be inheriting the properties and the behaviors from the base class or from the parent class. I will be using base class and parent class terms interchangeably during this session. But the basic idea and basic premise is like that only, that there will be a child class and there will be a parent class. And the child class is extending from the parents class. Remember the word extend because we are going to use that. And I've just shown you the what you see here is basically the official definition, which is given by Java docs here. We can read the definition as well. And the basic idea which I told you lies in the parent and child relationship. And this is how you can conceptualize it, that you will have a base class or a parent class, and then you can have multiple children of it. And then those children can again have their own children, and so on and so forth. So this hierarchy, this whole inheritance hierarchy can go as deep as you want it to be. And that's the basic idea and basic conceptualization of how you understand and how you visualize inheritance. Now let's move to Eclipse IDE and try to understand this with the help of an example. So for this particular case, I have created a set of classes basically, which we will be using to demonstrate the relationship of inheritance. And I've taken the simple example of a bicycle. So a bicycle is again a very generic definition of any two-wheeler, and bicycles can have multiple types. There can be an all-terrain bike, there can be a mountain bike, there can be a city bike, there can be a bike which is specifically made for ladies, and similarly there can be multiple different types of bikes. But all of these bikes will have some similar properties. For example, all of them will have two wheels. All of them will have a seat. All of them will have brake. All of them will have some sort of a speeding mechanism, whether they can accelerate or de-accelerate. So there will be some commonality, but at the same time, a mountain bike's features might be very different from a city bike feature. A mountain bike mountain bike might have gears, for example, whereas a city bike might not have gears because you don't need that much of a variation in inclination and declination when you drive down the road. So I'm trying to conceptualize the same example here where I've created a class called bicycle, and this is my base class. I define two properties in the bicycle class, which is gear and speed. We will come back to protected in a while, but let's leave that there. So I have two properties, which is gear and speed. I have a constructor where I'm initializing the starting speed and the starting gear. And then I have three methods here, which says set gear, apply brake, and speed up. When I apply brake, the speed is going to get reduced. So that's why you see minus equal to unary operator. And when I'm trying to speed up, the speed is going to increase. That's why I'm using the plus equal to unary operator. So when you use the method speed up, the speed is going to be increased by the value you supply in the method. Similarly, when you apply the brake, the speed is going to get reduced by the amount you supply in the method argument. And that is my base class: bicycle, gear, speed, and three methods. Now let's have a look at the child class. So the way you will define the inheritance relationship in Java is by using this extends keyword. Remember, I told you to remember the extends keyword. So what you will do, that you will write your class name as usual, and then you will use extends keyword, and then you will use the parent class name or the base class name. So here I'm saying class mountain bike extends bicycle. And here I'm providing an additional property. Remember the whole commonality versus differentiality equation. So a mountain bike might have an extra property to adjust the seat height. So that's the extra property which mountain bike is having. And then since this mountain bike is extending the bicycle class, this mountain bike class has the responsibility to initialize the bicycle class as well. And the way it will fulfill that responsibility is by taking all the arguments of bicycle class plus the mountain bike class in its constructor. And that's why you see three different properties here. You see the start height property, which is the property of this particular class, which is the seat height. And then you see the start speed and start gear property, which directly are not available in this class, but this class is inheriting those properties from the base class. Remember the keyword inheritance here. And then once you do that, how do you initialize the base class constructor is by calling the super method. This is again a keyword in Java, and you will use this super keyword to refer to the base class constructor in this way. So what you will do technically is that you will write super and you will supply the arguments which is required by the base class constructor. If I go back, the base class constructor requires two arguments, start speed and start gear. So I write super and then I write start speed and start gear. So whatever I got from here in the constructor of mountain bike, I'm supplying those values as is to super. And Java will automatically take care of invoking this particular constructor the moment it encounters this kind of statement. Another thing to notice is that this super keyword or super statement has to be the first statement inside your constructor. Remember that whenever you are dealing with inheritance and whenever you have to initialize the super class constructor or the base class constructor, use the super constructor invocation as the very first statement inside your child class constructor. Otherwise, Java will not compile the program. And then you will initialize the local variable. I should call this as this. Remember, we discussed about this in the classes session. Okay, and then it just has a method of set height. So there's no extra method which this mountain bike is providing, but this mountain bike will have access to all the methods which have been provided here and all the properties which have been provided here. This mountain bike can access everything from the bicycle class. And that's the whole idea of inheritance, that the child class can access the properties of the base class by extending the base class. Now let's look at how do we invoke this particular class. So for that, I have a simple class name as inheritance demo, which has a public static void main method. And then I am initializing the mountain bike class. I'm supplying three values as 20, 10, and 1. So the 20 goes to start height. The 10 here goes to start speed, and 1 here goes to gear or the start gear. And that's how I'm setting the values. So when I call this particular constructor here, the mountain bike constructor is going to, this mountain bike constructor is going to get called, and which in turn is going to call the base class bicycle class constructor as well, and everything will be set accordingly. And then let's try to access the gear property. Remember, gear is not directly available in the mountain bike class, but I'm still able to do mountain bike.gear because child class can access the parents class properties. Similarly, the same thing goes for speed as well. And seat height is the local property of this particular class, mountain bike. So it will anyways be accessible. So I can access all the properties of the base class and the child class itself seamlessly without any differentiation. Now let's try to call a method. So here I'm calling the method apply break. Remember, apply break was defined in the base class, not in the child class. It's defined here. So I'm calling the apply break method, and I want to reduce the speed, the current speed, by 1. And then I'm printing the current speed, saying that bike speed after applying break is mountain bike.speed. So let's run this particular program and observe the outputs. Okay, so the first statement which gets printed is at line number 7, which says gear is 1 because it's coming from here. Then the seat height is mountain bike.seat height, which is 20, which is the first argument here. And then the bike speed is 10, which is coming as here and getting printed here. And then when I apply the break, let's go back to the apply break method. The logic is that whatever is the current speed, reduce it by the value I supply in the method. So if I supply 1, 10 minus 1 becomes 9, and that becomes the current speed. If I supply 5 here, the current speed will be 10 minus 5 equal to 5. Let's assert that particular assumption as well. Yes, we can see that. And similarly, you can access other methods of the base class as well. If I just do control space here, and you can see apply break is accessible, set gear, set height, speed up, all the methods which are defined in the base class are accessible in the child class as well. This is the power of inheritance. One more thing which I said I will come back to is around the usage of protected access modifier. Remember when we discussed about the access modifiers in the previous session, I said that protected is used when you are dealing with inheritance, that whenever you define something as protected, it will be available to be accessible in the child classes of the base class. So if I define this particular variable as protected, then this particular property will be accessible in the child class mountain bike as well. Let's play around this. Let's make this as private and see what happens. So if I make this private, now when I say private, the scope of this particular variable is within the class only, and nobody outside the class will be able to see it. And you can see the effect of it. I can see an error being coming here in my inheritance demo class because now mountain bike object cannot access the gear property because the gear property is defined in the base class and now it is private. That's why the child class now, mountain bike class, cannot access the property gear. And the moment you make it back to protected, it will be accessible. The error is gone. There's no red line here. So that's how you can use the protected access modifiers. It is always recommended to use them when you write any kind of inheritance logic. And in inheritance logic as well, intentionally, if you want to hide a particular property from the child classes, just make it private. And that's all I want to cover in this particular session, where we dive deep into the concept of inheritance. We had a look at an example using the bicycle and mountain bike kind of construct, and you can apply the same kind of construct on any kind of other kind of business requirement. Remember, the is a relationship. So that's all I want to cover in this particular session. And in the next session, we are going to talk about another very interesting concept of Java, which is about encapsulation. Let's get started with encapsulation. So again, let's understand what is encapsulation in general, and then we will apply that concept to Java. Encapsulation, if you try to break that word, if I just write it here in the form of a comment, it's encapsulation. Just trying to break this word into to make it more visual. So you see a word called capsule here. So if you try to imagine a capsule, why do you create that, and what's the concept of a capsule? Capsule tries to pack a lot of things inside a small tube-like shape. And the concept of encapsulation is sort of inspired from that. Not exactly, not literally, but that's the basic idea of this root word, which is called encapsulation. So encapsulation basically means to restrict accessing the properties of a class to the outside world. If you want to protect the properties of your class, how do you do that? You do that with the help of the concept called encapsulation. So here this is a sort of a security feature. You can think of it as a security feature that you want to protect the properties of your class, and you will use encapsulation to protect the properties. How you implement encapsulation? Let's have a look at that now. So basic idea is to encapsulate the objects, create sort of a capsule around the object which can provide that protection layer. And you will define how the outside world is going to access the properties of the class if needed. So I've created a simple class here, and it's if you remember one of the previous examples when we discussed about classes, I used the same class, which was the student class, and I'm just using the same class for continuity. So I've created a student class here, and I have created 3 different properties of this particular class, which is name of the student, age of the student, and address of the student. You see, intentionally, I have used the keyword private in front of these 3 properties. And that is the first thing which you need to do to implement encapsulation on your object, that you hide all the properties from the outside world. Remember, the moment you make anything as private, only the class, which is the student class itself, only the class itself can see these variables or these properties. Nothing outside the student class will be able to access the name or age or the address directly from the student class. It's not possible. That's the whole idea of making it private, because you don't want the outside world to access these properties. So you make those properties as private. Then you create a constructor. The constructor has to be public so that anybody can initialize the student object, because you want your object to be accessible. Remember, so you want the objects to be accessible, but you want the restriction on the access of the properties of the object. And these are the properties of the object. So you have restricted them by making it private, but that doesn't solve the problem, because there will be some illegitimate consumers of the student object which should not have access to the student properties, but there will also be some legitimate consumers of the student object which should be having access to the properties of the student. For example, the payroll application will need access to these particular properties. The examination application will require access to these particular properties. So how do you do that? You create getters. We call them getters because they start with the keyword get. So you create a getter method for each of the property. You create the method called as get name, and this is the naming convention which Java promotes, that you write get and then you write the name of the property in camel case. So you write get name, and this property is supposed to return the name property of this particular object. And here you say return name. So you're returning the name which is being stored by the current student object whenever somebody calls student object dot get name. And this is the way you have restricted the access of this particular object as well. So remember, you made it private so that nobody can access it. And then you defined your own way of providing access to the name property of this particular class. Now, if anybody wants to access the name value of your student object, there's only one way to do that, which is via calling get name. So you have provided restrictions, and you have also provided prescriptive guidance on how you are going to expose the properties of your class. That's the second thing which you need to do to implement correct form of encapsulation on your object. That is to provide the getter methods with the right visibility. You want to make them public so that anybody can call them, but since you are governing what is written inside the method, you have full control on what kind of exposure you want to give for this particular property. Similarly, you create a getter for age, calling get age, which returns the age, and then you call you write get address and return the address. Here it is simply returning it, but if you want to do more stuff here, feel free to do that. like I said, you govern the control of how do you want to return the name. Maybe you don't want to return the complete name and you want to just return the initials. Then you can split the string, trim the string, and return only the initials. So that's the basic idea of getters. Now, after you have created the object, there might be use cases where somebody needs to overwrite the values of the properties like name, age, or address. What if a student's name was incorrectly mentioned when they called the constructor and now they want to overwrite the name or fix the name? So basically they have to replace the existing value of the name with a new name. So in that case, you need to provide what we call as setters, and they start with set. That's why we call them setters. And we follow the same kind of logic that you provide the setters for all the properties of your class. So you had three properties, which were name, age, and address, and you provided the setters for all three of them. And how do you provide that? You again make them as public because you want the outside world to access this setter method to override the values of the name. This method is not going to return anything, so it is going to be void. Then you write the name of the method, which starts with set, and then the property name in camel case. And then you provide the new value, which is the value which should be the new value, and this is the value which should replace the existing value. So whatever new value you want to supply, you supply that as the argument of the setter methods for set name, for set age, or for set address. And then you write this particular line, which says set the current name property of this particular object with the name which is coming in from the argument. So this dot name, remember, this dot name represents the current object's property because this represents the current object. So whatever is the current object property value of the name is, just override that value with the argument coming in. Do the same thing for age in set age method, and do the same thing for set address in the set address method. So this is how you are going to provide the setters and the getters. So setters and getters can also be generated in smart IDEs like Eclipse. So you just right click, you go to source, and here you will see the option of generate getters and setters. If you click on this, it will give you the list of the fields which are available to be having getters and setters. Currently, it says no fields or all fields have getters and setters already. Yes, because they have it. Let me just comment this and show this how this works. So for example, let me comment all the getters and setters. So I'm commenting them. And if I right click, source, generate getters and setters, I get all the fields available for which setters and getters can be generated. So you can select them and leave everything as default, hit generate. And it is automatically going to generate the getter and the setter. You see, all the code of the getter and setter is automatically generated. You do not even need to write it. And this is the power of the smart IDEs. Let me just revert what I did. So you created everything as all the properties as private, and then you define how you want to replace the values by providing the setters, and you define how you want the outside world to access your properties. So you have full control of the class now. You control the visibility, you control how they are going to get initialized, you are controlling how the properties are going to be overwritten or set, and you control how the properties are going to be returned. So you have complete control of the class. So you have created a perfect capsule here, a perfect form of encapsulation in this class. And this is how you can implement encapsulation. And that's all I'm going to cover for this particular session. In the next session, we are going to discuss about abstraction. Let's get started with abstraction. Let's first understand the definition of abstraction before we relate this to Java. Abstraction generally means hiding something. When you want to hide some details of a particular object from the outside world, you apply the concept of abstraction. For example, when you drive a particular car, you just hit the accelerator and the car speeds up. Now, it's not only one action. When you hit the accelerator, the whole machinery of the car and all the components, different parts of the car work together to speed up. There would be engine, there would be propulsion, there would be fuel, there might be some, if it's an electric car, there would be batteries, there would be whole different kinds of pistons and plugs which will make the car speed up. It's not only a single component, it's a lot of different components under the hood. And that's the concept of abstraction. that we only show the relevant parts to the user and we hide all the internal details from the user. That's the basic idea of abstraction. So a car manufacturer abstracts away all the inner technical details from the driver and just gives the driver a single pedal to speed up the car. For a user, it's a very good experience because he doesn't need to know about all the internals of the car. But the car manufacturer can hide all the details and provide a very simple interface for the driver to interact with, which is just a gas pedal. And that's the basic idea of abstraction. And we try to apply the same kind of concept to Java in the form of abstraction. And Java provides this kind of concept implementation with the help of a keyword which is called abstract. Now, abstract is a keyword which can be used in front of a class or a method. When you use it in front of a class, the whole class becomes abstract. Abstract class is a type of class. So the class itself becomes an abstract class. One of the things to remember is that abstract class cannot be instantiated, but can be subclassed. Remember, we talked about the concept of subclass and the parent class when we talked about inheritance. So if you make a class as abstract class, you cannot call the constructor of the class because you cannot instantiate it, but you can extend the abstract class and create a child class out of it. That's the concept of abstract class. Another concept is abstract method. You can also use the abstract keyword in front of a method. And when you use abstract keyword in front of a method, then that method is only declared without an implementation. You are not going to provide any implementation of the method, and you're just going to declare the method. Something like this. We will see a similar example in the hands-on as well. But that's the basic idea, that you just declare the method. You are not providing an implementation as to what does move to method actually does, because that's the whole concept of abstraction. And it is the responsibility of the child classes which inherit the particular class in which the abstract method would be sitting. So that child class will be having the responsibility to provide a concrete implementation of the declared method. Let's understand this better with the help of an example. So here I have created a class called graphic object, and I have made the class as abstract class. This is the keyword which you need to use in front before the class keyword, and the class becomes an abstract class. Now, when you create an abstract class, it automatically gets some properties. The first property is that this particular class must have at least one abstract method. And this is how you define the abstract methods, where you just provide the declaration, but you do not provide the implementation of the draw method or the resize method. And the way you will create the abstract methods is by using the abstract keyword before the actual method declaration starts. So general method declaration would look like this. And if you use abstract in front of it, this becomes an abstract method declaration. Abstract class can also have concrete methods. So that is the liberty which abstract class gives you, that you can have abstract methods which are just declared, but you can also have normal methods which are where you can also provide the implementation. So you can have normal methods and abstract methods as well in an abstract class. So this is the abstract class. Now, if you want to provide an implementation of the draw and resize method, you have to extend this abstract class. So we extend this abstract class by creating two child classes out of this particular abstract class, which is circle.java, where you can see I create a normal class and I use the extends keyword for inheritance. And I'm saying that circle class is inheriting from the graphic object class, which was my abstract class. And once I use this extends keyword, then I have the responsibility of providing the implementation of the abstract methods. Actually, Java will force me to provide the implementation of these two methods. If I do not provide all the declared methods, so there are two declared methods here. So if the circle class does not provide the implementation for both draw and resize methods, then Java will throw an error and it will ask you to take an action, which can be either define all the methods, meaning provide implementation for all the methods, or make the circle class itself as abstract. Let's see, if I just comment this particular out, I get an error. You see a red line here. And if you click on this particular balloon here, it will say either you can add the unimplemented methods or you can make the circle type as abstract. So these are the two options which you will get to fix this particular error. So an abstract class can be extended by another abstract class, if the child abstract class is not implementing all the methods of the parent. If you want to implement all the methods, then just implement them and keep it as a normal class. And that's what I've done here. I've just created a normal class here and provided the implementation. And once you provide the implementation of both of the methods, the error is gone. Similarly, I've also provided another child class because there can be multiple children of a particular parent. So rectangle also extends from the graphic object, and it also provides its own implementation of drawing and resize. Because generally the way you will draw a rectangle and you resize a rectangle will be different than drawing or resizing a circle. Here I'm not doing anything in the methods because this is just to show you the demonstration. I'm just printing a sys out saying drawing a circle and resizing drawing a rectangle and resizing a rectangle, and in the circle class drawing a circle and resizing a circle. So one abstract class as the parent class, which is the graphic object, and two children, circle and rectangle, both providing the implementation of the abstract methods which were declared in the base class. Now let's go to the main class where I've defined the public static void main method. And here you see I have created two different kind of blocks of code here. One block is where I'm saying graphic object, creating a reference of the graphic object named as circle and initializing the circle object. Now you see a difference here. Here is the abstract class and here is the concrete class. So whatever you define on the right hand side, whatever is the type of object will be the type of methods being called. So if you created a circle object and then if you call the draw method and resize method, these methods will be called from the circle class. If you initialized it as new rectangle, then you are creating a rectangle class object, and then the draw and the resize method will be called from the rectangle class. That's the basic construct, and that's how you will initialize a particular class which is using an abstract class. So I call graphic object circle, new circle, and I call circle.draw and circle.resize. Similarly, graphic object rectangle equal to new rectangle and rectangle.draw, rectangle.resize. Let's run this program and observe the output. So when I call this particular block of code, circle object gets initialized, and then circle.draw method prints drawing a circle, and circle.resize method prints resizing a circle. Similarly, when I create the rectangle class object, referencing it with the graphic object class, rectangle.draw prints this particular line, drawing a rectangle, and rectangle.resize prints this particular line, which is resizing a rectangle. And this is how you will use the concept of abstraction. There's another very interesting thing which is going on here. Remember I told you if I do this and I just put a system out here, base abstract class. So if I do this here, if I still write a constructor, though Java says that it cannot be instantiated, if I still write a constructor of it and I do not do any changes here, and if I run this particular program, let's see what happens. You'll see the base abstract class being called here. Let me just reformat it by putting ln here so that we get a better output. So if I run this particular program, you see base abstract class is getting printed somehow, though we said that abstract classes cannot be instantiated, but still the constructor of this is still getting called somehow. When I create a circle class, the base class constructor gets called, and when I create a rectangle class, again the base class constructor gets called. This is the power of inheritance, because in inheritance, remember how it works. When you initialize a particular child object, referencing it with the parent object, see the reference is of the parent class and the object is of the child class. So whenever you do it like this, first the default constructor, because I'm calling the default constructor here, the default constructor of the circle class will get called, which will go here. Remember I told you that Java provides the default constructor automatically if you don't provide it. So the default constructor of circle gets called, but Java sees that you are writing this code here, which says circle extends graphic object. So Java is automatically going to call the parent class and going to initialize the parent class as well, because that's how it will be able to see these methods. And so that's why it will automatically call the base class constructor, even if you don't call it explicitly. In fact, you cannot call it explicitly. Java will not allow you to initialize the graphic object class explicitly. It can only and only be called by Java itself indirectly via the concept of inheritance. If you try to do this, let's try to do this for fun and also for better understanding. So if I write graphic object go equal to new graphic object, you see I don't even get an option, but let's write it and let's see what happens. So you see that this particular, it gives basically an error because it's not able to find the constructor of the graphic object class. Though even I have defined the default constructor here, but still Java is not able to find it because this class is abstract. So hence proved, abstract classes cannot be instantiated explicitly. They can only be instantiated by the child classes through the internal mechanisms of Java itself. And that's all I want to talk about in this particular session, where we looked in detail about the concept of abstraction. Couple of more things which I did not cover in the previous session. I just want to call them out for clarity. Java does not support multiple inheritance. When I say multiple inheritance, what it means that you will not have a scenario where a child will be extending from two base classes. Java does not support it. It does support it with the help of interfaces, but I will talk about interfaces in the coming sessions. But here, just understand this, that you cannot use multiple inheritance with classes in Java. A child cannot have two parent or two base classes in Java. Java will not allow that. It is also called the diamond problem because the child class does not know whether to follow the route of base 1 class or the base 2 class if it is extending from two different base 1 and base 2 classes. So a class can only extend from one class in Java. We can find a workaround of it by using the concept of interfaces, but that's something which will be coming later. Another thing to understand is that when you create an abstract class, here these variables, you can declare these variables as well. And these variables will be accessible by all the child classes as you access them. Let's get started with polymorphism. So polymorphism is a very generic concept, which means that a particular object can take multiple form. Let's not even call it as object. Let's make it more generic. A particular entity can take multiple forms. If any entity in Java exhibits that kind of behavior, then we say that polymorphism is in action. That entity can be a class or an object or even a method. And in today's session, we are going to talk about that type of polymorphism which is exhibited by methods. So we will see how a particular method in Java can take many different forms containing different logics, but still having the same name. And that concept is called method overloading. So whenever you hear the word that you need to overload a particular method or this is method overloading happening, technically or conceptually, it's basically polymorphism in action, and polymorphism is being applied on a method here. And that phenomena we call as method overloading. So in today's session, we are going to have a look at how we can implement method overloading in Java. So the basic idea of method overloading is that the name of the method should remain the same. So you see in this particular class, which I have created to demonstrate the method overloading. So this is the class name, and the method name, which I am going to overload, is called multiply. And that is probably the first thing which you need to remember to implement method overloading correctly, that the method name is going to remain the same. The type of the return of the method may change. Here you see it's returning int here in the first instance. In the second instance also it is returning int, but in the third instance it is returning double. So the return type of an overloaded method can change. Another thing which can be varied between same method being defined again and again is that the number of arguments and the type of arguments. The first multiply method takes 2 arguments of integer type. The second multiply method takes 3 arguments of integer type, and the third multiply method takes 2 arguments of double type. So by using method overloading, you can vary the number of arguments and also the type of arguments. So the basic idea is that you define the method using the same name, but you do a variation in the arguments or the return types. And that's how you technically implement method overloading. In this particular case, the multiply is the method being overloaded. And in the first case, it is accepting 2 integer arguments and returning the result of multiplication of those arguments. In the second case, the same method name multiply here, the same visibility public, and the same return type, but this time 3 different types of integer values can be accepted, and this method, multiply method, is going to return the multiplication of 3 integer numbers. In the third case, at line 15, I again use the same multiply name, the method name, but this time the return type becomes double, and this method accepts 2 double arguments and returns the result of the multiplication of these double values. So the method name is same, but the arguments vary, and also the return type may also vary. That's the basic premise of how you implement method overloading. So whenever you want to implement it, keep the method name same, vary the arguments and the return types. And after that, I'm just created a public static void main method here. I have initialized the class here, this particular class itself, method overloading demo. And then I am calling the multiply method on the object. And based on the number of arguments I supply, the corresponding method will get invoked. That is something which Java will take care automatically, that whatever type and the number of arguments you supply in the call, in the invocation, based on the number and the type of the arguments, Java will try to find a matching method in the overloaded methods. If it is able to find a method, it's going to get invoked. If it is not able to find the method, you will get an error. In fact, you will get a compile error itself while you invoke a method for which the definition is not available. For example, if I try to just copy this and make an invalid method invocation, let's provide 4 arguments. And if I do that here itself, I will get the error because Java is not able to find a multiply method in this particular class, which is accepting 4 integer arguments. So you will get the compilation error itself before you can even run the program. But the basic idea is that you use overloading with multiple different types and the number of variables. So I'm calling multiply 3 times. Let's run this particular program and observe the output. So let me just bring this output down. Yep. So first I call demo.multiply and pass 2 integer values 10 and 20. When this happens, this particular method gets invoked and it returns a result of 10 into 20, which is 200. In the second invocation, I'm calling again the multiply method, but this time with 3 arguments, 3 integer arguments specifically. And this call is going to match this particular method signature, and it is going to execute whatever is written inside this particular method, which is the multiplication of the 3 arguments being supplied. So 10 into 20 into 30, which is 6,000. The third case, let's go back here at line 25. The third case of invocation of the multiply method is accepting 2 decimal based arguments, 10.5 and 20.5. So Java is going to look at the class and trying to find a method which can accept decimal values. And there it is. This is the method signature which is going to match the invocation. Java is going to do this matching automatically for you. And here, whatever logic you have written inside this particular method will get executed. So 10.5 into 20.5 returns 215.25, and that's the output you get. So this is how you can use method overloading in Java. This is a rather fairly simple example, but you can make it as complex as you want. But a word of caution, do not use it too extensively. In fact, a lot of expert programmers do not recommend using method overloading because it becomes very confusing. Use it only when you do not have any other way out. Use it only where this is the only way to write correct form of methods with the right readability. Otherwise, generally, there would be other ways to avoid method overloading by writing concrete purpose-friendly method names themselves. Maybe you don't need to use the multiply name again and again. You can call it as multiply 2 numbers, multiply 3 numbers, multiply doubles, so that the method name itself is more explicit and understandable rather than juggling around different signatures of the same method. Especially it becomes more confusing if you are creating an interface which is to be consumed by a third-party developers or third-party application. So try to use it with caution. That's what I'm trying to stress here. Let's get started with method overriding in Java. So in the previous session, we discussed about method overloading concept. Now, in this session, we'll focus on another interesting concept by which you can have the same signature of the method again and again be used in your code, but in a different way. And this concept is called method overriding. Method overriding basically is used together with the concept of inheritance. you will not be able to use the concept of method overriding without using the concept of inheritance. Remember, when we talked about inheritance, I spoke about the subclass and the parent class concept. Sometimes we also call the parent class as superclass. So the basic idea is that if a superclass defines a method, remember I'm using the word define here. If the superclass uses defines a particular method, and then the subclass again tries to define the method with the exact same signature, this phenomena is called method overriding. Now, when you do method overriding, there are some rules to follow. And I'm showing you a tabular structure here, a table basically, which will show you what is possible and what is not possible when it comes to method overriding. So let's try to understand this table. So if you try to define a method with the same signature as a superclass method, the rules follow as per this table. Let's go with the first one. If you have an instance method defined in the superclass, instance method is the normal method which you define in your classes. So if you have defined an instance method in your superclass, and if you define a method in the subclass with the exact same signature, then that concept is called method overriding, and it will be a successful override. Override also, let me also explain what override means here. Override means that once you try to initialize the subclass object, you will be able to invoke its own overridden method definition. If you call that particular method, the subclass's own instance method is going to get invoked rather than the superclass's instance method. We'll look at that when we look at the example as well. But that's the normal scenario where your superclass defines an instance method and subclass also defines an instance method with the exact same method signature. That concept is called method overriding. What if your superclass defines a static method? Static method is basically a method which belongs to the class but not to the object. Instance method is called instance method. A normal method is called instance method because it belongs to the object. You can call the method on the object, but static methods are called by class. So you say class name dot static method name. But when you call instance methods, you just call object name dot instance method name. So that is the basic difference. The static methods belong to the class. Once you have defined a static method, the same static method will be available to all the objects of the class. But instance methods are unique to each object. So that was a short tour of what static methods mean. So if you define a static method in the superclass, and then if you try to define an instance method with the same signature in the subclass, you will get a compilation error. It will not be allowed. It's not allowed in Java to override a static method from superclass. That's what it says. Next one, if your superclass has a normal instance method and then the subclass tries to use the same signature but creates a static method out of it, then again you will get a compilation error. So that the overriding of an instance method to a static method is not allowed. And the last concept is again a very interesting concept and a very popular interview question about method hiding. So if the superclass defines a static method and the subclass also defines the static method with the exact same signature, then the superclass's static method gets hidden. It basically hides the superclass method. So that's the basic idea behind method overriding. So if you see, technically, it's a form of polymorphism because the same method is having multiple definitions. But when we looked at the previous example, the multiple definitions were in the same class. Here, the multiple definitions are in different classes, and those classes are having a parent-child relationship. That was about the theory of it. Let's go to an example of it to understand it better. And I've used again the same construct of bicycle and mountain bike, which we have been using in this series just to maintain continuity. So I have a parent class called bicycle here, which has two properties, gear and speed. It has a constructor, nothing unusual there. And then it has defined three methods: set gear, apply brake, and speed up. Set gear is just setting the new value as the gear value. Apply brake is going to decrement the speed by the value you supply, and speed up is going to increment the speed by the value you supply. Simple. This is exactly what we have seen before. Now, mountain bike tries to extend bicycle. So mountain bike becomes a child class. it defines a variable called seat height, defines a constructor called super here, nothing unusual so far. Also defines a setter for height, setter for the seat height, not exactly following the setter construct, but this is just to set the height. But here things get interesting. Let me just bring this down a bit. Yeah. So here it is overriding all the three methods of the base class. And by overriding, it is providing its own implementation of the same methods. Let's compare them. Here, when it overrides the gear and whatever value you supply, it adds 2 to the plus 2 to that value and then sets that value as the gear value. But in case of base class, it was just setting the new value as the gear value. So for instance, if you supplied 1 here, the gear value becomes 1. But here, if you supplied 1, the gear value becomes 3. Similarly, when you apply break on the mountain bike class, whatever value you supply will be subtracted from the current speed, and 10 would be subtracted even more. So if the speed is, let's say, 50 and you supply the decrement value as 10, so it will be 50 minus 10 equal to 30. But in case of bicycle, if the speed was 50 and you supply 10, then it would be just 50 minus 10, 40. So there is extra 10 being subtracted from the speed when you apply brake in case of a mountain bike. Similarly, for speed up, it's increment of 10 in addition to what value you supply. So again, if the speed was 10 and you supplied 10 here in the argument, so 10 plus 10 plus 10, 30 will become the new speed in case of mountain bike. But in case of bicycle, if you supply 10 and if the current speed was also 10, then it becomes 10 plus 10 only 20. So that's the difference. So the basic idea, I hope you get the basic idea here, is that you override the methods and your own class provides its own implementation of those methods. That's the basic premise. This is also fine. There will be no compilation error because speedup has a concrete implementation in the bicycle class as well. So it's up to you how much you want to override. So let's move to the main class now. So in the main class, we have created the public static void main method here, and let's look at what is happening inside the class. First, we initialize the bicycle class. So bicycle class reference and bicycle class object. Nothing unusual here. We supply the gear value and the speed value. Then we print the gear and the speed value. We apply brake on the bicycle, and then we observe the new speed of the bicycle after applying the brakes. Let me comment out the rest of the code and let's observe the output for only this part of the code, which we just walked through for this section. So if I run this as a Java application, and if I show you what I'm getting here. So bicycle gear is 1, which is what you supplied in the constructor. Bicycle speed is 10, which is again what you supplied in the constructor. Then you applied brake, and when you apply brake, this logic gets executed. And you supplied 1 here, so current speed was 10, so 10 minus 1 becomes 9, and the new speed becomes 9, which is what you are printing here. So far so good. Let's move on to the next section. Let me comment out the previous section now, and let me uncomment this section. So here I have a bicycle reference, but the object is of mountain bike. Remember this concept, this is called dynamic object binding concept or dynamic binding concept. Again, this might be asked in your interviews. So here I'm initializing the mountain bike with a reference of bicycle. Remember, whatever is written on the right hand side will govern the variables and the methods usage. We'll see how that works out, what I just said. So I'm supplying 3 values here, 50, 50, and 3 in the mountain bike. If I go here in the mountain bike constructor, so the start height, start speed, and gear are the 3 values, which is supplied as 50, 50, and 3. Then I'm accessing the gear and the speed. Now remember, gear and speed are declared in the bicycle class, but they are accessible in the child class due to the inheritance phenomena, which we have already covered. So if I print only this part, I should get the expected values. Mountain bike gear is 3, which is what I have supplied here, and mountain bike speed is 50, which is what I have supplied here. Then I apply the brakes. Now let's move on to this section. I apply the brake, supply the value as 1, and then I want to see what would be the new speed after applying the brakes. So let's see what happens when we run this particular code. So if I run this code, after applying the brakes, the speed becomes 39. Before applying the brakes, the speed was 50. So what happened here is 50 minus 1. Basically, this logic is getting executed here. 50 minus 1 minus 10, which becomes 39. That's why you get the value as 39 as the new speed. Similarly, if you want to call another method as speed up method was also defined here, where I'm saying speed plus the argument supplied plus 10. So the current speed is 39 right now. Then I'm speeding it up by 10. So by this logic, 39 plus 10 plus 10, which will become 59. And then I'm printing the new speed after speeding up. So let's see what happens. So if I go to run as Java application, and if I observe all the outputs, the speed was 50 initially. After applying the brakes, the speed became 39. And after speeding up, the speed became 59. So this was a quick demo to show you the power of method overriding and how you can override the behavior which is defined in the base class. And let's get started with exception handling in Java using try and catch blocks. So in the previous session, we had a look at the scenarios where an exception can occur. How do we see that there's a runtime exception, or there's a checked exception, or there's an unchecked exception, or there is a custom exception. Now, we did not talk about how to handle those exceptions, and now we are going to focus on the handling part. So whenever you have to handle those exceptions, the way Java provides for that is using the try catch block. So try catch block is basically a bunch of syntax which you have to follow to handle different types of exceptions in your programming code. And the syntax of the try catch block is pretty straightforward. You write try and you put curly braces, and then you write whatever code which might throw an exception. You don't know that, but it's always safer to enclose your code in a try catch block so that you know that if an exception occurs in the try block, then you can handle it in the catch block. So it's always considered a better practice to enclose your application code in a try catch block so that you can handle the exceptions. So you put this try block and write all the suspicious or non-suspicious code which may or may not throw an exception inside the try block. Once you have done the try block part, then comes the catch block part. So let me go to the catch block. So this is how the syntax look like. Once you have written the try block, then you write catch and you put braces and you write the exception type which this block of code might throw, or the exception type which you are interested in catching. You might not be interested in catching all the different exceptions, but only a few ones based on your business requirements. So whatever exception type you want to catch, you are going to catch it like this. And if an exception occurs in the try code, let's say you have specified an arithmetic exception here, and if any line of code in the try block throws an arithmetic exception, then this catch block is going to catch that exception. And then inside these curly braces, you can decide what to do with that exception, whether you want to log that exception or whether you want to rethrow that exception, whether you want to embed some error code or get an error code out of it, or convert that exception into a business or custom exception of your own choice. So it's up to you what you want to do with that. But catch block will be able to catch that arithmetic exception. Similarly, you can specify as many exception types to be caught as you want and keep adding more and more catch blocks. Remember that these catch blocks work in a sequential fashion. So if an exception occurs here, it will first go to this particular block to match the exception type. If it didn't match, then only it will move to the second type. If it did match the first type, it is not going to execute the second type. So that is how the try catch block work. You can see an example here that if the code here is throwing an index out of bound exception, then it is going to be caught here. And we are just printing the index out of bound exceptions message. If it is throwing an IO exception, then I can do this. So you can keep adding different checked and unchecked exceptions in the catch block. You can also catch more than one type of exception with one exception handler. So rather than writing these multiple catch blocks individually, you can combine these exceptions together if your logic of processing both of these exceptions is the same. Remember, if the logic of processing these two exceptions is the same, logic means whatever you write inside these curly braces. So if that code is going to be the same for both of these exceptions, then why bother writing two catch blocks? just write one catch block like this. Use the pipe operator to separate different types of exceptions and write the common code which is going to be applied if your try block is going to throw an IO exception or an SQL exception. So that depends upon you. That's the second piece. The third piece of the try block is the finally block. So we talked about the try block, we talked about the catch block. Now there's a finally block as well. Remember, this is finally and not final. The finally block is used together with the try catch block when you want to perform some cleanup operations. Imagine you are opening up a file handler in the try block, you're doing something with it, and then you want to just close the file handler irrespective of the fact if there was an exception in the try block or not. Because even if there was an exception, the file handler resource is going to remain open and is going to consume memory in your application. You don't want to do that. Similarly, if you opened a database connection inside your try block, irrespective of the fact of what happens in the try block, you always would like to close the database connection. And you can write that closing code in the finally block. That's the purpose of the finally block, that you can write the code inside the finally block, which is supposed to be always executed irrespective of the fact whether an exception occurs or doesn't occur. So now we have built a good understanding of what is the try catch, what is the try block, catch block, and the finally block. Now, if you just put it all together, this is how it is going to look like. That you write the try block, you do something inside the try block, then you write the catch blocks. After that, you write the finally block. You can write the finally block without the catch block as well. Remember that if you do not have any exception to catch, but you have some resources to close or free up after executing the try block, you can skip the catch block and just write try finally. That is also possible. With that understanding, let's switch to the IDE and let's look at some example. So I have a writer helper class, which is having a method called write